The Airbus A350 and the Boeing 787 are two quite innovative and elegant looking airplanes which have helped to reshape the aviation industry thanks to their high levels of automation, comfort, and most importantly, efficiency. But what really makes these two planes stand out from other airliners is their widespread use of composite materials in their construction, which has brought significant weight savings and made these planes fuel efficient. However, these planes may soon be victims of their own success and pose an environmental nightmare if proper actions will not be taken. But how is that even possible? Let's find out. The 787 and the Airbus A350 are basically made from composite materials like carbon fiber, and these materials have a huge disadvantage in that they are very difficult to recycle once they reach their shelf life. But before we look at the reasons as to why these materials may pose an environmental nightmare, first let's look at how these planes are constructed from composite materials. Traditional airliners like the Airbus A320, the Airbus A330, the Boeing 737, the 747 among many others are made from metals like aluminum alloys. Aluminum has great benefits in that it is lightweight as compared to steel, and also it has a high resistance to corrosion. I'm sure that most of you are aware that when most planes are in the air, they have to be pressurized. Pressurization, in short, involves pumping air or oxygen into the plane's cabin in order to have a safe and a comfortable environment for the passengers to breathe normally, because the air at the high altitudes where most planes travel is very thin and thus not breathable. The air pumped inside the cabin is equivalent to that found at an altitude of around 8,000 feet. When the plane is finally on the ground, all this pressurized air will then be pumped out of the cabin and the cycle will continue. This process results in the airplane's fuselage or skin slightly expanding once the plane is in the air because of the pressurization, and then shrinking again once it is on the ground. This expansion and contraction of the airplane's skin form its pressurization cycles. The time between one takeoff and one landing makes one pressurization cycle. Airplane age is measured in terms of the pressurization cycles encountered, and most planes can bear around 27,000 pressurization cycles, which is equal to around 27 years of service. Pressurization makes an airplane age because all the expansion and contraction over time forms tiny cracks on its aluminum skin, causing what is called metal fatigue. Metal fatigue is a huge drawback of aluminum, and this is why modern airplanes like the Airbus A350 and the 787 are made from composite materials. Composite materials are made from carbon-reinforced plastics bound together by a plastic resin in order to make them strong and rigid. Composite materials are very strong, even stronger than steel, while having a fifth of its weight. Planes like the 787 are normally made in sections whereby automated robots wrap a carbon fiber tape around a rotating mold of the fuselage. This carbon fiber tape is impregnated by a plastic resin. The fuselage part will later on be baked in a large autoclave oven in order to cure the plastic resin and create a solid composite structure. Composite materials are advantageous in that they are immune to fatigue. Therefore, planes like the 787 and the A350 can be pressurized at higher pressures without developing cracks as aluminum would. These planes can handle a cabin pressure equivalent to that at 6,000 feet, and this helps make the flight more comfortable and reduces jet lag. This is the reason as to why the 787 and the A350 are called special planes. We have now seen that composite materials are strong, light, and immune to fatigue. So, what drawbacks do these materials have? Well, for one, these materials are very expensive because of their production methods, since they have to be cured in large ovens, which are very expensive to create. And both Airbus and Boeing had to make massive investments in creating composite facilities for making their groundbreaking airplanes. Another disadvantage of composite materials is their difficulty in recycling. Metal or aluminum airliners are often scrapped once they are retired, and the metal scraps can be used for making soda and beer cans, among many other things. Around 80 to 90% of a metal airplane can be recycled, and the parts which cannot be recycled will be sent to landfills. Valuable parts like the engines, landing gears, and cockpit instruments can also be reused on other airplanes, hence minimizing wastage. Carbon fiber is difficult to recycle because of the plastic resin binding it together. This resin is difficult to separate during the recycling process, and this often results in carbon fiber getting dumped into landfills. This results in environmental degradation while tampering with the aesthetic beauty of the land. And once many A350s and 787s reach their retirement age, they will have to be stored in deserts or airplane graveyards till a solution on how they can be recycled can be determined. And if a solution won't be found, these planes will pile up and become expensive yet useless waste. One solution can be reusing composite materials on other airplanes. Carbon composites can be recovered and reused again. Therefore, they can find use on other airplanes. Boeing is currently testing out this approach on their Boeing 737 Eco Demonstrator airplane, whereby they have made some of the plane sidewalls from recycled carbon fiber obtained from the Boeing 787 and the 777X production lines. And I think this can be scaled up and applied to other airplanes once 787s and A350s are retired. Another application can be in the electronics industry. Dell has recently expressed interest to use recycled carbon fiber from the Boeing 787 production lines to make some of their laptop components. As a side note, the Boeing 787 and the Airbus A350 are not completely made from composite materials. Composites only make up around 53% of the structure of these planes, with the rest being made from metals like aluminum, steel, titanium, and other metals. The metals present on the airframes of these planes can be recycled, with parts like the engines, cockpit instruments, and landing gears being reused on other airplanes. All in all, the time to adopt more carbon fiber recycling techniques should be now, or otherwise, we the inhabitants of our beautiful planet will be the ones to suffer. And that brings me to the end of this video, and as usual, I hope you have learned something new. In case you're new here, my name is Martin and welcome to the Skyline, and please subscribe for more great aviation content coming soon. Otherwise, thank you very much for your time and have a nice time ahead, and please take care. Goodbye.